Okay, today you want to sketch perfect graphs, okay? Perfect graphs. And so we're going to kind of take a little bit of what we did earlier and apply it today. We're going to add a couple new pieces. Number one, you want to consider the domain of a function when you graph it, okay? For example, does anybody know what the domain is of y equals the square root of x? Yeah, domain is going to be from 0 to infinity. How about y equals 1 over x? What's that domain? Everything except 0. X cannot be 0. So there you have it. Make sure that you're thinking about the domain of a function. Okay? Domain of a function. The range is obviously the outputs. Another thing that we like to determine when we're sketching graphs is the x and y intercepts. How do you find the x-intercept? Oh, we set y equal to 0. How do you find the y-intercept? Hey, set x equal to 0. I wouldn't worry about symmetry too much. That just kind of happens. Asymptotes, you should be able to consider asymptotes. For example, y is equal to 1 over x minus 3. That has a vertical asymptote at what value?
3.
Yeah, 3. That's a vertical asymptote. It also has horizontal asymptotes. That's something that we would find out if we did lesson 4.4, or we're skipping lesson 4.4. Okay. Intervals of increasing and decreasing. Increasing happens when what? You're on the ball. What do you got? F prime is greater than 0. Good. Decreasing when? F prime is less than 0. Cool. Local max.
Oh, positive and negative.
F prime changes positive and negative. Min.
Negative to positive.
Negative positive. Concavity. Concave up when?
F double prime is greater than 0.
And then F double prime is less than 0 is concave down. What do we call that spot where it changes sign? Inflection. So inflection occurs when F double prime changes from positive to negative or negative to positive. We're looking for a sign change there. The pieces about increasing, decreasing, local max, local min, concavity, inflection, that you really need to memorize for the test. We are not going to focus on end behavior for this test, even though it will come up and we'll discuss it. I probably won't be critical about how I ask questions about it, okay? So we want to be able to create 2 full graphs that are extremely accurate, okay? Again, the whole point is to go to where Isaac Newton was. How can we discover information about that graph without the use of our calculator, okay? Calculator. I'm going to start with the intercepts. I think that the intercepts are great. But even before that, I'm going to start with some end behavior here, even though we didn't really talk about it. What does that shape look like? Yeah, see, you guys know a lot about it already. You know that the general shape of this graph, does it look like the blue one, or does it look like the red one?
The blue one.
The blue one, because it's positive, yep. Remember we talked about in chapter 3 last year, where we talked about polynomials, the different shapes, up, down, things like that. So you've got the general idea. We're not really going to write much there. Just when it says end behavior, we want you to think that it ends up and it starts down. That's the general idea, okay? You okay with that? All right, let's talk about intercepts. I'm going to find the y-intercept, and I find the y-intercept by setting the x value equal to 0. What do you get if you plug in 0 for x?
0.
You get 0. So 0 is the y-intercept. The way that I come up with the x-intercepts is I set the function equal to 0. X cubed minus 2x squared minus 3x. How can I solve that? I factor it. As I factor out an x, I get x squared minus 2x minus 3. Or x minus 3 times x plus 1. So where does it cross the x-axis?
0, 3, 3.
Yeah, so already we got some interesting information. And last year we took time to kind of look at that and we sketched it, but you guys were like, well, how high do I draw it? How low do I draw it? Well, now we can figure that out because that occurs at the local max and local mins. What do you think my next step is to be able to generate this graph? Take the first derivative to start to talk about some of those pieces. So what I need to see on your test is I need you to see a first derivative at some point. So this first derivative, f prime of x, is equal to what? Minus 3. Does that factor? Nope, it doesn't. Okay, it doesn't. So what are you going to do if it doesn't factor?
Use your calculator.
Go to your calculator. You guys all have the quadratic formula typed in, right? Once again, on this test, you may not press the graph button. Okay, we talked about that. I don't want you just sketching these graphs, but you could use the quadratic formula if you so chose. Program, execute. My quadratic formula isn't in there. That's too bad. I thought I already did it, but it's not there. Sad day. Can somebody on their own produce the answers for the quadratic formula through their program option?
Yeah, 1.8685.
Okay.
And then negative 0.535.
Great. So whether you do a number line test or whether you make a graph, we know that the first derivative, it crosses the x-axis at 1.868 and at negative 0.535. What shape does my graph make? Parabola that's right side up. We've encountered that before. So what information do I glean from that? Increasing from? Negative infinity to what? Negative 0.535 union 1.868 to infinity. Decreasing in between that, so from negative 0.535 to 1.868. What else does the first derivative tell me?
Local maximum, local min.
Yeah, the local maximum is going to occur at what x value? Why at negative 0.535? Because the derivative changes from positive to negative. The local minimum occurs at 1.868. Notice that those are points, those are intervals. So I'm going to find the y values, but I'm going to use my calculator to help me find the y values in a little bit. All right, what is my next step here? Second derivative. Second derivative, look at that. Second derivative is going to be super easy. I have f double prime of x is equal to what? 6x minus 4. So as I graph that, where is that going to cross the x-axis? At 2/3.
Happy Wednesday.
Is this a line that goes up or does it go down?
Up.
The line goes up. Okay. Second derivative tells me obviously about my concavity as well as my inflection. So the concavity will be concave up from 2/3 to infinity and negative 2/3. I'm sorry, negative infinity to 2/3. At what point do I have inflection? At 2/3. So what I would encourage you to do at this point is you've got your intervals figured out. I would then encourage you to go to your calculator to be able to produce the rest of the values. And so when I say go to your calculator, produce the values, what I'm referring to is take this and plug it into your y equals. So x squared minus, or x cubed minus 2x squared minus 3x. Let's see, we've got y equals clear. X to the third minus 2x squared minus 3x. And although I don't want you to graph, you can go to the table and you're just gonna type in your values for your inflection as well as your local max and min. If I recall, those values are negative 0.535 and 1.868 and 2/3, so 0.6 repeating. As I enter those, I now have y values. My y values are 0.88, 0.88, negative 6.06, and then what was the output for 2/3?
Negative 2.593.
Negative 2.59. So again, I would like to make an exceptional graph. I'm going to make a graph in an 8x8 window. Does everybody agree that if I make an 8x8 window, that will capture all this information? It sure will. I'll make it by twos. 2, 4, 6, 8. Wasn't it nice of Mr. Luther to join me for lunch today?
I'm not sure, how did it go?
Not like yesterday.
It was great. There are no asymptotes. Look at our polynomial. Polynomials don't have asymptotes. Okay. Our next one, we will look at asymptote. What points would you like to start to plot?
The intercepts?
Yeah, the intercepts, it goes through 0, it goes through -1, and it goes through +3. We're also going to plot our local maximum, which is at -0.5 and +0.8. I'm going to estimate that right about there. So again, we ask, how high does it go? That's its highest spot in that region. Then how low does it go? 1.868. We go all the way down to -6.06. Are we okay with how I've created the points? Yeah, and then we have 2/3, so 0.6 repeating. So it'll be right about here. We go down -2.59, so something we're right about there. So we even have our inflection. Look at the vast number of points we've been able to plot now. So as I go ahead to sketch this, that's my shape. Now you could have made it different. You could have made your x values only go, say, out to -4 and +4. But just to show you how accurate we are, if we keep that image in our brain, I'm going to go to my calculator, and I'm going to go into my window, and I'm going to go from -8 to +8. I'm going to go by twos, and then again -8 to +8, and I'm going to go by twos. And we'll see if our graph there is an accurate representation of what we have. What do you think? How do we do?
Yeah.
Grade me. Hannah, give me a grade. Scale 1 to 10. Come on. That compared to what we see on our graph.
9.6.
See, I'm giving myself an 8.
You weren't.
This seems like a little bit wider, you know what I mean? Like mine seems a little bit sharp and choppy. Like I need to do some extra work, don't I? Okay. Give myself an 8.
Oh, it should be a 9.
All right, last example. Flip it over. What's different about this one?
-2.
Yeah. Very good. So Hannah sees right away that there will be a vertical asymptote at x is equal to -2.
How do you know whether it's vertical or horizontal?
If it's undefined at this, it's undefined at x equals -2, and that is a vertical line. Okay? Now, here I'm going to show you something kind of neat. You don't have to do this on the test, but I'm going to show you it's something that's kind of neat. Okay? It's a little trick here. I can see right away that the horizontal asymptote is y is equal to positive 3. I know it right away. And what it means is if you were to take the greatest thing in the top, which is 3x, and divide it by the greatest term in the bottom, x, what would you get? 3. You see that? Suppose it was 4x plus 2 over 2x minus 1. You just get 2. See that? That's all there is to it. Suppose you had this. Suppose you had x minus 6 over 3x plus 1. 1/3. You see that? Simple. Okay, so let's go to the intercepts now at this point. How do I find the y-intercept? And if I plug in 0 for x, I get 3 times 0 over 0 plus 2, which, as you said, is 0. So another y-intercept of 0. In order to find the x-intercept, I set the function equal to 0. Is a fraction equal to 0 when the top is 0 or when the bottom is 0? When is the top equal to 0? At 0. So 0, it goes through the origin, and that's all we really know for the intercepts. Okay, that's all we really know. Okay. All right, we got to figure out something to create this graph. We know we've got a vertical asymptote at -2, so I'm going to go back 2 units, and then 1, 2, 3 for the horizontal asymptote. Let's make a little 3x3 graph here right now. Vertical line at x equals -2. Hi there. Horizontal line at y equals 3. And it has an intercept of 0, 0. Does anybody have an idea what this shape looks like already? You probably do. We're still going to use the calculus to confirm it. It's not too bad, but let's find our first and second derivatives. So you maybe already have an idea what this looks like. Let's use our calculus to confirm it. We have f prime of x is equal to, how do I find this derivative? The quotient rule. What is the derivative of the top? 3 times x plus 2 minus, which is just 3x, all over x plus 2 quantity squared. What do you get in the top?
6.
I get 6, and in the bottom, I have x plus 2 quantity squared. I'm simply going to look at a number line test here. What number should I plot on my number line? -2. I will test numbers to the left. I'll test numbers to the right. But some people look at this and realize that this is, why is it always positive? Squared in the denominator, that's going to make it positive, and the top is positive. So therefore, positive and positive. What does that tell me about our characteristics of our graph? It's always increasing. You cannot include the -2, so you must write from -infinity to -2, union -2 to infinity. Is it ever decreasing? No. Does it have a local max? No. Or a local min. Never changes sign. So I can be absent on both of those. Talk to the person next to you. How would you go about finding this second derivative? Talk, go. Okay, what rule did you talk about? Oh, you used the chain rule, so you rewrote this as 6 times x plus 2 to the negative 2 power? Could you use the quotient rule? Yeah, it gets messy. I don't really care for it in that situation. I think that that's easier. Notice that if it was a 6x, then I don't like to do that as much because now you have the product with the chain. If it was 6x over that, I just use the quotient rule in that situation. I don't care for the negative exponents as much, okay, within the product rule. So I'm going to do that. So I'm going to outline this as 6u to the negative 2 and x plus 2. And the derivative of x plus 2 is 1, and the derivative of 6u to the negative 2 is negative 12 over u cubed. And so my derivative is negative 12 over x plus 2 cubed. True or false? That's always positive. True or false? That's always negative. False. If you have a cube, you can't say anything about positive or negative. Okay? It changes. And so we do plug in the value of negative 2. Or we make that our test in our number line. Hattie, what number would you like to test to the left?
-3.
If we test negative 3, we get negative 3 plus 2 is negative 1. Cubed is negative 1. A negative divided by a negative is a positive. Emma, what number to the right of negative 2 would you like to choose?
2.
Okay, we plug in 2, we get 4. 4 cubed. Okay, positive, negative over a positive is a negative. Hannah, you were going to choose which number?
0.
Yep. So we have negative and positive, each their own. It's America. Right? Do what we want.
Which seems just wrong.
Okay. Well. So what we know from this is we have concave up from negative infinity to negative 2, concave down from negative 2 to infinity. Should I list negative 2 for my inflection?
No.
Why?
That's not part of the domain.
It's not part of the original domain, so you technically do not have a point of inflection. I had a student once upon a time got really angry with me about that. Said it changes at negative 2. But again, an inflection is a point, and there's no actual coordinate that you can plot. If you choose negative 2, there's no output there, so you can't plot it. So that's why. I get the point. But now it tells us where we can draw it. Notice, and it confirms our answer for us, there should be no mistake here. It's always increasing, and it has to go through this point, and it follows the asymptotes. So this graph should look like that. And if it's always increasing and it's concave up, will it be in the bottom quadrant or the top quadrant? The top one. And that's your shape. Notice concave down and increasing, concave up and increasing. That's an excellent graph. All we need to do. Those are examples similar to what we've seen. Tomorrow I want to do one that we haven't seen, and then we'll be given time to work. Please look at your assignment so I can show you what you do and don't do. Within your, after your 4.3 work, you're going to see a worksheet on 4.4. Please skip problem 4.4. Okay?
Okay. So we do all of the 4.3s?
What's that?
All of the 4.3s?
Yes.
Okay.
Some of those are just AP practice problems, so you kind of start getting a little bit of a guess and idea. Okay? On your 4.5 worksheet, there are 8 problems. The last 2 are optional. The last 2 are optional. So 7 and 8 are optional problems. Okay? I cannot tell you how important the first 6 are. Okay? And as you look at the first 6 with me, just so we can be on the same page, okay? The first one is a cubic that's upside down. Have you done a problem like that before? Yes, you have. Problem number 2 is a quartic. We did one in class, but you've not had one in assignment. So number 2 will look a little bit different for you, okay? Number 3, again, is a cubic that's upside down. 4 is a quintic, okay? So you're going to be discovering a little bit there. Number 5 shows very, very similar to what we just did. And then 6 will take a little bit of discovery, okay? So I will reduce the study guide. Actually, I'm going to print out the same study guide and just show you guys the questions to cross off from section 4.4, okay? And we'll reduce the test by that amount as well. Sir?
Are the study, are the answer keys posted?
Oh, no,
I will hopefully have that, I'm giving tests the next 2 hours, so I'm gonna have some desk time. My goal is to update my calendar at that time. Yes, Emma, you may. Okay, rest time is yours during the,
I have my hand up first.
He sees my hand first.
you know what, I'm going to Ally.
Ah!
Hannah!
It's okay.
Alright, Alex, now how
You're
what
right.
we got now?
It is.
It's like you have another tab. Like,
Turn it ready, bomb.
Maybe not.
That's you back over. That's you back over.
I found it.
Wait, what is this?
Oh, it's too late for you and your wife.
Oh my gosh,
Yeah,
I saw on
TikTok
TikTok the other day.
What?
I saw on TikTok that was like, your birthday, it tells you which song you are from this.
What was that conversation?
I don't know, but mine was Paper Rings.
I like jumping on
You know what kind of you?
It's not
Have you ever
very
heard this Brian Jordan?
Have you heard of the teacher?
I did, because I saw it in a lot of random videos. So
Can you write your favorite like a Mine's really bad too, like, that's not, I've seen a lot worse.
I mean,
Yeah,
it's
I've
gotten
seen
better
that.
over time. I actually,
Just let me
yeah,
know when
that's,
it's-
yeah, it's not so good.
Mine's not that good either. I don't really care. Do you write everything in system or just?
Alright, all over.
Yeah.
It's just.
It's like tennis, but yeah, it is though.
It is.
Okay, say my name.
That's
You
not
bring
bad.
pen too?
Good, thank you.
All your math work?
I don't know.
You just don't make mistakes, you know? Like my guy.
Hello.
We saw.
Got it.
What? We saw one.
Is that it? Look at that, good for you. I'm gonna go help Hannah,
Yeah,
I'll be
you
back.
will.
Then Hattie, rocking your hot gloves today, huh?
Mhm. I got that.
Yep.
But now you multiply by 2, right? You get a common denominator or something?
The whole common denominator thing, kind of a pain in the butt, huh?
Oh, you need to multiply by the whole thing.
Yeah, you good?
Maybe.
Yeah, you give that a shot,
Wait,
okay?
Hannah, you said October 24th?
She's wearing a shirt that has the rock on it,
So is
so,
she.
oh wow, is it his birthday today or anything?
No.
Oh, so then you
It's
just
for
get 2
swimming.
on the top.
All right, wow,
Yeah, did you
it's
say
not even
how
swim
old?
season.
Did you say
Yeah, we got
October
it for
24th?
our banquet.
Okay,
So
I
from
like it, because you guys are the rocks.
your
Way to go.
love stories.
Way to rock, okay.
From Reputation.
I did.
I know you explained it
The
yesterday,
new
but
one.
I'm still finding.
Yeah, shut up.
I got the
Sorry,
rest
I'm
of
going
it.
through all the slides.
Sink like a rock is.
From Reputation, your dress.
Think like a rock.
Oh, because then it's just.
1989, your Shake It Off.
Has exactly 2 zeros.
Oh, yeah.
I thought you shake it
So
off.
or your
That
invisible
means that G prime is
string.
equal to 0. So it never goes to 0. But the values are
From Lover,
G is D.
you are the man.
That's because you're not.
What?
What is it going to be
I've heard that.
Oh.
It's not. I should have just asked it.
Your lunch.
I have either. It's where it's below.
There's a lot of juniors now, so where's G prime?
Oh.
-2.
Your empathy.
Wait.
Don't know that one.
Right, so G prime, right, so where G prime is less beautiful and X value.
I don't know.
That give us that. This is the output, so G prime is negative, but what X value is.
Not our thing I've ever done.
So that's why they have a lot more.
This is why we can't have nice things.
I'm scared because it's not.
That's all because
You know what?
it says, notice how it
Oh,
says
that's
that
fair.
it only has 2 zeros. So
Oh,
that means it
last
never
API was
crosses through
super
0
duper
again.
easy. The
That means
test,
that once it crosses through
I
0,
will
it's
say,
gonna
like,
be negative after that. So
it
it's
more just
negative
like
right
depends on
after
all of,
negative 2.
like, previous knowledge. It's like,
So if this is
he's
negative,
like a
that
fun
means that
teacher,
everything
but like
between
she's not
here is
great at
negative.
preparing you
So
for
from
tests.
negative, it's not from
So,
You're
negative 2
Let's just
to
say, there's
positive
this girl
2.
that's been sitting.
It's from
We've
negative
been
2
talking
to
about our
positive 2.
protons and electrons for like the past 2 weeks.
What about
See, but
April?
that's-
April,
She
because she
goes,
told them this.
Nice.
tiny circles, the electrons.
I know art.
I wore so to be clear.
Oh, your love story.
I mean, this was like.
I
at
love
least she had-
stories.
Yeah.
That's true.
Oh,
And I think
I
it was
love that
probably-
song. Okay.
How many minutes are?
And then from
There were like
Reputation.
12 minutes, not 1%.
But,
I
yes. I mean,
This is a college class. There was like.
You're also
Yeah,
dressed.
that's
She's also
Every
dressed.
other number was
the
that.
She's dressed.
knowledge.
She's
From
so
that
matter.
perspective,
Negative.
How many?
You're shaking off.
Seconds?
Ew.
okay?
She's also shaking off.
Yep, exactly. There are times when the AP examiner chooses this, when I feel like they should choose that.
Your invisible
So
strength.
I don't know why, and I
She's
won't say
invisible.
a good answer, but people can say AP ain't doing that either, but.
okay.
Better? Okay.
No, just kidding.
You'll get pissed. I don't have you might get pissed on.
Negative 2
I wrestled
plus
before.
3
I was paper.
1.
Yes.
Okay, figure it out.
Take care of that.
That's right.
Yes, let me switch on log. I talked to each other. Yeah.
Can you end my pass?
But if I don't end the pass, then you won't be able to move around next hour, walk the hallways again.
But I
So I'm
need,
just trying
I
to
need to
think
go to
about-
the library
Trying to
next
think
hour.
about how do we keep you,
In class?
yeah, how do we keep you from smoking in the bathroom?
I do it every day.
She's just admitted
Say something, say
We
something.
haven't had to close the bathrooms yet this year. That is awesome.
Ooh, almost died.
You two rocking the pause.
I'm not gonna forget your phone charger in here today. Oh, okay, I'll
There you
wait.
go.
Are you gonna post the video for tomorrow?
That will be my 100% goal, yes.
Okay, and then can I pick up the study guide after school?
Thank you.
Daddy.
Oh wait, no, I can't. I'm not.
Oh, Addison, by the way, I'm going to the go.
Okay, wait, you're not here.
Yeah, I got my side of it for like a long time ago.
Yes, same.
And? You did? Maybe he got it for himself.
I'm gonna
Maybe
eat it.
he got it for the dog.
If you
Maybe
do-
he actually got it
If you
for the
cry,
dog.
you guys have this.
Maybe he's having snacks. We're on there. Very possible. Probably should.